All right, I'm here with some live coding in Rust, and I'm going to mix things up a little bit today in that I'm going to show how to develop in a new cloud-based environment for Rust called AWS CodeCatalyst, which is pretty interesting because you can either do it in the web, which is one way to get things cooking, or you can also tell it to use a machine that Visual Studio Code talks to through the AWS toolkit. So I'm going to go ahead and share my screen here and show how this works. So first up here, if we have Rust data engineering repo that's been checked out, but the part that's going to be unique here is look in the left corner here, we have Code Catalyst, and we can see that it says stop. So this means I'm running an environment. And even though I'm on OS 10, you'll see that if I type in uname-a, look at this. I'm actually running on Linux, so I'm running Amazon Linux. So this is a great way to develop, actually. And if you want to see how many cores I have, they've already pre-installed some stuff on here. In this case, we have htop command. So htop is a lot of times not installed, but I'm glad it is. You can see here that we have 16 cores, right? So, ooh, that's pretty cool. Something's cooking here. And in fact, even further, if I type in which AWS, you can see, in fact, some AWS tools are already installed for me. So this is a pretty interesting environment to set up. And then I told it to talk to a repo that I already had working for some Rust code. And look at this, we can see all these different examples here as well. So it has essentially the essence of competing with GitHub code spaces. That's really what this environment is about with Code Catalyst. And I also, if I wanted to, could even open up the settings here, and we could actually configure this further. So look at this. We can see I can stop the instance if I want. I also can look at the dev file.yaml and open that up in the editor. And I even can edit the kind of compute. So if we typed in edit compute, look, I can go small, medium, large, extra large. If I want to edit the timeout, that's another one I could edit. So pretty cool here that you actually have a lot of ability to edit this remote instance. And look at this, the components here, we can see that the image is actually using a public ECR image called the Universal Image Latest. So this is a little bit different than, let's say, a traditional, Amazon Linux 2 instance, in that this one is optimized for the Code Catalyst environment. So very interesting stuff, right? Like this is all new things here. Now, a couple other things I'll point out about this environment is we also have Code Whisperer. And Code Whisper is the generative AI assistant that you can use to help you write code. And so if I go through here, and all I'd have to do is connect my AWS Builder account. So I'll go ahead and do that in another window, and it will open it up. And all I have to do is auth it and then say allow. And then once I've done that, basically you'll see that Code Whisper is actually now running as well. So essentially very similar to GitHub Codespaces plus Copilot. And if we want to actually start coding some stuff up here, that would be a good way to test it out. Now, the first thing that I'll point out is that unlikely that Rust is installed, right? So if I type in which Rust C, there is no Rust compiler. So what I'll need to do first is actually run the rust up command. And so let's go ahead and do that. And we can see here that it says basically we're going to do all these things to our environment here. And by default, we're going to proceed with installation. And this is going to install the Rust environment. There we go. And then the first time you run Rust up, unless you want to source your bash RC, you have to actually run this. Okay, so now we actually have cargo. And so if I wanted to, I could actually do a hello world example here. Now, it is interesting as well that if I do a get pull, that it will actually have automatic ability to work with this other environment, which is pretty cool because of the integration with the Code Catalyst environment. And I guess I could test this by just editing a README just to double check that the GitHub integration is working correctly. We can just say, for example, maybe right here, we can say like, environments, and we can say works with both AWS Code Catalyst. So bad at spelling code catalyst here. It is CATALYST and GitHub code spaces. And let's go ahead and just double check that that works. So if I do git add, I type in readme, let's say commit. I can say adding more documentation about CodeCatalyst. There we go. Yeah, looks like the push is successful. So we know that it works seamlessly to actually have this other environment here, which is again pretty cool. Now, the other thing that we would probably want to test out here would be to just build a project using CodeWhisper and CodeCatalyst and just kind of kick the tires a little bit. So maybe like a Polars Hello World would be kind of a fun one. So if I type in cargo new, say Polars Hello World, and we call this CodeWhisper. So I can show that I use CodeWhisper, and I just cd into here like that. And then what I could do as well is I like to use a common makefile, so I'll just go ahead and do that. I'll just copy PageRank, just another random makefile into here. And then if we go to Polars Hello World CodeWhisper, we see we have a makefile, which again, these are the common commands that I like to do, which are format, lint, test, run. And then inside of here, we have our main. So let's go ahead and just run it. So we'll just type in cargo run. That's good. But now what I want to do is actually get Polars to actually work inside of here. So this is the part where I would actually want to test this out. And so what we'll need to do is put in Polars here, but I need to look at the right crate here. So Polars crates, let's go ahead and find the latest one here, which I think is going to be the 0332 would be the latest one here. And let's go ahead and try that out. Although I think I'm just looking through the dependencies here, the README here, data frame, is that if we click on Polars, we can just throw it in there. There we go. It looks good. And then I'm gonna go ahead and do a cargo run, and this should install Polars. Now, what's interesting about Polars is that it can handle huge data sets, which does make it different than the Panda stuff in Python. And so that is a plus, right? That's a huge plus here. And so one of the things that is kind of a traditional Hello World, I can just grab one of their examples and just try that actually. So I would most likely want to put in, a example here. We could say a Polars Hello World script that uses AWS CodeCatalyst and CodeWhisper. There we go. Okay, so now I would want to just say use the Polars prelude. So it was able to autocomplete that pretty well. So Code Whisperer is already helping me out here. And then I think we would want to build a function that would read some data remote. So one of the things that is a little bit tricky to figure out is where, let's use the iris data set. So we'll say like the iris data sets in GitHub. Let's see if I can find one from somebody and just basically pull this from somebody's account, and we can just say raw. Here we go. Here's an iris data set. So I'm going to write a function that, well, let's see, how tricky do I really want to get here? Do I even care about the iris data set? I guess I could. So I could just wget it. That's probably the easiest way. Just follow my own advice and say that we can make a directory called data, cd into data. I could wget iris. There we go. So there we go. So now that I've got the iris data set, the next thing to do would be to read in the iris data set. So let's go ahead and read in the iris data set. And so in order to do that, what I would want to do is create a new function, and we would just say fin read iris, read iris, and process. And so we would just read in process. We'll say read in process iris. So yeah, we do want to return a data frame. And then I'm going to say like, let's see, let's query equal. We can try the lazy CSV reader. Now in this case though, ours is going to be in data iris. So we're going to say data iris CSV. There we go. That looks good. And then we're going to say it does have header. That it does. So this is pretty cool. Like, so what we're seeing here is that Code Whisperer, especially for one-line completion, is pretty good, right? And let's just do finish. That's all I care about. And let's return back the query here. So if I just do that, I believe the implicit return here will work. And then I would just say, we just want to actually print this out. We can say let results equal read and process, and then we would just print the result in here, which would be basically, I forgot to do this in, well, we would just actually pass it in. We could actually just say let result, we could say, or no, let's say df, let's call it df, the data frame, that, and then wouldn't it just be df.collect? I believe should work. There we go. Let's see if this compiles. So I'm going to format it first. Oops. Oh no, I need to go up a directory. So we'll go ahead and format this, and then let's lint it. Double check. I didn't write any super sloppy code. Uh-oh, we got problems. Expected data frame. And did I not return it? Is that the problem? Let's see here. So let's solve this one. You might be missing. Oh, so we need to change that. So I don't even need generative AI. The Rust compiler is so good, right? It just tells me exactly how to fix this. So that's one problem, right? And we can overwrite. And then fail to resolve use of undeclared type, lazy reader. Huh, that is weird. So that seems a little bit strange here, but let's try to do it again. Format it, lint it, and so we can say this is not an iterator. So let's just do this. Let's just say print out the data frame. Let's see if Code Whisperer is smart enough to know. No, because I think, well, maybe we don't want to do lazy reader. Let's look at, maybe we actually, the lazy reader would be great for a big data set, but we don't really care about that. So I need to look into the documentation here and see, like, could we just do this, right? And what would happen if I just tried that, for example? Go ahead and compile and see what happens here. Make formats. We can say cargo run. And required by CSV reader. So that's actually not working here. Oh, you know what? I didn't load the lazy feature. That could be an issue. So let's try that. That could have been an issue. That the feature was not. Well, that would make sense. So if we go back to cargo, I'm going to delete this, and then I'm going to run what the documentation tells me, which is, oh, I guess it said, okay, it added it. Great. So now, if we just say, just do the collect like the documentation says. So it says df.collect. And then let's close out. Let's see, does anything work? So I guess that's one issue, is making sure that you've installed the right dependencies. Could be a gotcha and could be a little bit tricky to debug. So we can see here it's actually building Polars lazy. Now collect, I'm assuming what it does is it basically says, hey, because you did a lazy query, now I need you to collect the query, right? And that can be really useful for a large data set, right? You wouldn't necessarily want to run it. Now this says data frame is not an iterator. Returns implicitly this. So I think, do we have to actually say query here? Is that what the dot unwrap? Is that what it is? Let's try that. So what is going on here? Implicitly returns this as its body has no tail or return expression. So did I not save that? Let's try this. And so df collect is not an iterator. Query down unwrap. Well, I definitely have some kind of a weird expected Polars data frame because of return type. Yeah, so I'm not I'm not actually returning. Oh, this is what it could be. I think I know what the issue is. So we'll say let df equal, wouldn't it be query.collect here, unwrap. There we go. That's the issue. It's the wrong return type here. And then we would say let df, and then we could just say print df. How about that? Or print, wouldn't it be this? Yeah, something like that. Yeah, let's try that. Now I'm, so, prints ln macro. There we go. So we're getting a little bit different stuff, which is good. So it says results Polars error is not an iterator. So do we need unwrap here? Why couldn't I just do that? Let's try that. Polars error is not an iterator. Yeah, so something in the documentation that I'm reading is not going the way that I expected. So what I could do is I could just look at one of my other examples here and see if I can find, although one person is saying you have to add either a return statement or remove the semicolon at the end here. Oh, is that the issue? Let's see here. Well, what I'm going to do is I already have a Polars somewhere here. I had a Polars example somewhere that I can find in my repo that was a little bit better than this. Let's look for Polars here. Polars. I think I can see, although there might be one in here actually. I thought I had a Polars example. It could be, I think it's in another repo. Let me find it out. So we'll say AWS Lambda Rust. That was one. Let's look at a Polars Lambda example. How did I do this before? Well, let me grab a, here's a, I'll just be lazy here. And I have another example I wrote that worked. So what I'll do is I'll type in source lib.rs, and then I will go to lib, and let's see, what did I do differently before? So this is just basically a hard-coded example where I have the data hard-coded inside, but the big difference, let's look here. So I have a calculate function. I see. So I return back the data frame in the Polars error. So in theory, just kind of looking at this thing, I probably could, CSV reader, and then I return back. So it's something like that might actually work. I'm kind of curious actually whether I could just swap that out. Let me see here. So if I went back here and I just threw this in there, and then the input would be CSV reader new, and it would be this. Let's try that. Let's get rid of that. Just kind of this thing. Get rid of this thing, which was deeply troubled. And if I look at this process, and we can just call this one calculate. Map. That's a good question. Maybe I do. Let's see. Let's try a cargo run here and see what happens. There's a method with a similar name, group by. Huh, I wonder if the API slightly changed here. Let's try that. Well, I'm having all kinds of problems. Well, sometimes live demos go well, sometimes they don't. But if I said this, let's try that. Just get rid of all that. Weird is, why is it still group by? I saved that. Maybe I need to do a make clean here, cargo clean. Let's try to run it again. This looks a little more logical because I think the one issue I had was not returning back the right type, which was an issue. This is simpler because all it does is just read the data frame. Let's see if this works. And the other mistake I had was there was no semicolon. In your return statement, it's better to have a more elegant one. So this is definitely weird here, in that what I need to do is probably delete this thing, probably causing all kinds of weird problems. rm lib source lib.rs, do a clean again, see what happens. This thing hopefully is gone. All right, so at least different errors here, which is the trait is not satisfied. So there's some issues here with my hello world, and this is probably a good place to pick up next week. So I'm going to go ahead and say get status and go up a directory here. So we'll say get add polars world, get this broken code. There we go. So I have a broken series of things I'm doing with polars. I need to fix it. That's probably a good thing to fix next time I do a live coding. All right, thanks. Talk to you then.